This is a session of 43 slides modeling the Common Core State Standards for teaching fractions in Grade 4. It is the second of a series of lectures modeling the standards for teaching fractions. The slides of this presentation are courtesy of MathWord Press, dedicated to teaching children mathematics through literature, on the web at www.mathwordpress.com. The most important thing to remember when teaching fractions is that a fraction is a number. Think of number as the adjective that tells us how much or how many. Number doesn't tell us what we have, just how much of it we have. The Common Core State Standards for building an understanding of fractions are found under the domain Mathematics, Number and Operations, Fractions. The goals recommended by the standards for grades 3, 4, and 5 are listed in the statements here. To accomplish these goals, this session will model each of the standards for grade 4 in both area models and on the number line. Note that in the slides of this session, the standards themselves are highlighted in gray. In grade 4, the standards have three objectives: to extend understanding of fraction equivalence and ordering, to build fractions from unit fractions, and to use equivalent fractions as a strategy to add and subtract fractions. The formal mathematical development of fractions begins in grade 4. The shift of emphasis from multiple models of a fraction in the initial stages of grade 4 to an almost exclusive model of a fraction as a point on a number line can be done gradually and gracefully, but the shift is implicit in the standards. First, let's review some important concepts covered in grade 3. Unit fractions are the basic building blocks of fractions, in the same way that the number 1 is the basic building block of whole numbers. On the number line, we find one unit or one jump between two adjacent whole numbers, for example between 3 and 4 or between 75 and 76. In the same way, we find a unit fraction between two adjacent fractions with the same denominator. For example, we find the unit fraction 1/4 between 3/4 and 4/4, and between 6/4 and 7/4. A second important concept from grade 3 is that the definition of the unit determines the value of the number. For example, if 1 is the volume of a container measured in pints, then 1/3 of the volume of the container is 1/3 of a pint. If 1 is the width of a piece of paper measured in feet, then 1/3 of the width of that paper is 1/3 of a foot. What we're saying is that the value of the number 1/3 depends on the context. It could be 1/3 of a cookie or 1/3 of an acre. Number only states quantity. Number doesn't tell us what we have. Number only tells us how much or how many. This flexibility in the interpretation of fractions as points on the number line is an important reason for using the number line model when studying fractions. Other reasons for using the number line to study fractions is that on the number line, children can visualize each whole number labeled in fractions. The two fractions are at the same point in the number line if they are equivalent, and that if two fractions are displayed on the number line, the fraction to the left is smaller than the fraction to the right. So let's begin to look at the Common Core State Standards for grade 4. 4NFA1 reads, explain why a fraction a over b is equivalent to a fraction n times a over n times b by using visual fraction models. Pay attention to how the number and size of the parts differ, even though the two fractions themselves are the same size. and use this principle to recognize and generate equivalent fractions. So the fraction a over b is equal to the fraction n times a over n times b. Children must grasp this concept. But where do we begin? Let's first take a look at this concept on the number line. What happens to any fraction when only the numerator increases? Consider fourths, 2/4, 3/4, 4/4, 5/4. Or consider the whole numbers expressed as fractions, as I did at the bottom of this slide. We see in both cases that when only the numerator of a fraction increases, there are more and more of the same size parts, and the number becomes larger. Again, looking at the number line, what happens when only the denominator of a fraction increases? When only the denominator increases, a unit is divided into smaller and smaller pieces. You can see here that 1/2 is a larger portion of the unit than 1/4, which is a larger portion of the unit than 1/8. When only the denominator increases, the unit is divided into smaller and smaller pieces. But what happens when both the numerator and the denominator both increase by the same multiple? We have a greater number of smaller pieces, and these pieces equal the same part of the whole. I'll repeat that. We have a greater number of smaller pieces, and these pieces equal the same part of the whole. Square Bear would say, I don't care how many pieces you cut it into, as long as I have all of them. For children struggling with the concept of equivalency, let's return to the area models, the rectangular area models we used in grade 3. In this slide, we see a whole, or a unit, divided into halves, fourths, sixths, and eighths, a greater number of smaller parts. Again, Bear doesn't care how many pieces you cut it into, as long as he has all of them. As children work with area models that represent the whole, you can lead them to discover this concept. When you have all of the pieces, you have the whole. 4/4 equals the whole. 7/7 equals the whole. 10/10 equal the whole. In general, when the whole is divided into n equal parts, if you have n of those parts, you have the whole. Many children comfortable with the number line model for fractions have already realized that for all values of n, the fraction n over n equals 1. But as we saw in the last slide, area models for the whole can also be used to recognize the value of n over n. This is important. From their work with factors, children already know that multiplying any number by 1 leaves that number unchanged. Multiplying by n over n is actually multiplying by 1. Once children use these area models to find fractions equivalent to the whole, they can look at fractional parts of the area that are equivalent. In these area models, we see some fractional equivalents of 1/2 and of 1/3. We should allow children to explore this idea until they're comfortable with fractions that express equivalent parts. But because children are also working with factors at this time, we can introduce the concept of finding common factors in the denominators of equivalent fractions. In the fractional equivalents of 1/2, they will find that 2 is always a factor. And in the fractional equivalents of 1/3, they will find that 3 is always a factor. The next standard, 4NFA2, asks us to compare two fractions with different numerators and different denominators. for example, by creating common denominators or common numerators, or by comparing to a benchmark fraction such as 1/2. Recognize that comparisons are valid only when the two fractions refer to the same whole. Record the results of comparisons with the symbols greater than, equal to, or less than, and justify the conclusions, for example, by using a visual fraction model. Because the standards don't offer a breakdown of 4NFA2, an A2A, or an A2B, let's break this standard down into sections. First, the standard asks us to compare two fractions by creating common denominators. From all their past experience with both area models and on the number line, students should understand that 1/2 is the equivalent of 2/4, but we should emphasize the number line, and they should express each equivalent in an equation. How many 1/4 parts of a whole equal 1/2 of the whole? Point out that 2 is a factor of 4, and write the equation. Comparing fractions with common numerators can be explored using area models, but always look at the number line. In this slide, we used common numerators just as we use common denominators. Sometimes fraction comparisons are easier with common numerators. Encourage children to look for the easiest conversion. And keep the fractions simple. Remember, the concept that they are teaching is the same number of different sized parts. Until children are comfortable with the concept, continue comparing compatible fractions with both different denominators and different numerators, still using the area models if necessary, but always include the number line model, and point out any common factors of each denominator, writing the equations and the inequalities. The standard also asks us to compare fractions using a benchmark fraction, such as 1/2. In this slide, we compare area models to the benchmark 1/2, and we also compare the fractions on the number line. Note that for each comparison, we wrote the inequalities. Initially, we will create simple problems that ask questions such as, which is greater, 1/2 or 2/3? But eventually, the numerators and denominators will become more complicated. Children should begin to feel comfortable with the method of multiplying by the multiplicative identity in the form of n over n. But always have students write the equations and the inequalities. The next directive is to build fractions from unit fractions. The standard for NFB3 reads, understand a fraction a over b with a greater than 1 as a sum of fractions 1 over b. To make this clear, I think B3 should read, understand a over b as the sum of a fractions, each the size of 1 over b. Now remember this statement from the 5th slide. Unit fractions are the basic building blocks of fractions, in the same way that the number 1 is the basic building block of the whole numbers. It's an important concept. We might begin to explore this concept of unit fractions in area models, as shown here. For example, we see that 2/3 is the sum of two fractions, each the size of 1/3, or that 4/3 is the sum of 4 unit fractions, each equal to 1/3. We can relate this concept to whole numbers on the number line. On the number line, the number 1 is located 1 unit to the right of 0, but we also find 1 unit between 4 and 5 or between 7 and 8. Any whole number can be perceived as built of single units. In the same way, on the number line, any fraction, any a over b, can be broken down into unit fractions, or 1 over b's. So we'll find the quantity 1 over b between 3 over b and 4 over b, or between 7 over b and 8 over b. Here we've used 1/3 as an example. In this slide, we use the simplest of unit fractions, 1/2, as a further example. We've located the number 1/2 at 1/2 a unit to the right of 0 on the number line. And then we used that unit to build other fractions, 2/2 and 3/2. Children may see this as 1/2 unit jumps on the number line. But this is a concept we introduced in 3rd grade. First, that a fraction, 1 over b, is a number on the number line, and it is located at the endpoint of the segment based at 0. And second, that the quantity 1 over b can be found anywhere on the number line, that we build other numbers, or other fractions, from 1 over b, just as we build whole numbers from 1. The next standard for NFB 3A reads, understand addition and subtraction of fractions as joining and separating parts referring to the same whole. This can be introduced as an extension of what we've been doing with area models. But now we begin to join together fractions with unequal denominators. When we do this, the combined fractions often produce a fractional answer with an area that cannot be expressed in either denominator. When this occurs, the question to ask is, how small do the fractional pieces have to be before we find a division of the whole, a denominator, that suits both fractions? Now let's look at the same concept on the number line. On the number line, I believe, joining segments end to end intuitively expresses the addition of numbers. Here we've joined 1/2 and 1/3, and you can see that the answer is 5/6. If number lines contain fractions in many denominations, results can be located accurately. Now let's look at the same addition using the multiplicative identity 1 in the form of n over n to find a common denominator. By locating results of addition of fractions on the number line, children can visualize original denominators as factors of the common denominator. Thus, the number line model allows children to determine the common denominator without performing the multiplication, and I believe it makes the common denominator more intuitive. The next standard, 4NFB 3B, asks us to decompose a fraction into a sum of fractions with the same denominator, and in more ways than one, recording each decomposition by an equation. It also asks us to justify the decompositions, for example, by using a visual fraction model. Again, I began with area models, which may still be useful for many students. Here we decompose 3/8 into 3 unit fractions of 1/8, or into 1/8 and 2/8. At the bottom, we also decompose 2 wholes, or 2 units, plus an additional 1/8. This 2 and 1/8 could be decomposed in many different ways. Though we can begin with area models, students should now be able to decompose fractions into many different parts on the number line. Here we've decomposed the fraction 6/4 into 3/4 and 3/4, 4/4 and 2/4, and so forth. But we have also represented each decomposition in an equation. Note that the standards view the fraction 6/4 as 6 of the unit fraction 1/4. In the standards, the concept of a mixed number is defined only after fraction addition has been defined, because the standards view converting a mixed number to its fractional form as fraction addition. The next standard is 4NF-B3C. Add and subtract mixed numbers with like denominators, for example, by replacing each mixed number with an equivalent fraction, and/or by using properties of operations and the relationship between addition and subtraction. Well, the property of operation we would use is the commutative property. We would add the whole numbers together and then add the fractional parts. In this slide, we see area models for both methods of addition of mixed numbers. We add 2 1/8 and 1 3/8. First, by converting the whole numbers to eighths and adding all the eighths together. And next, by using the commutative property to add the whole numbers and then add the fractional pieces. I believe the area model allows children to see this concept. What would this addition look like on the number line? In this slide, we add 2 1/8 and 1/8. We do it first by converting each whole into 8/8 and adding all the eighths above, or by adding the whole numbers and then adding on the fractional parts below. Subtraction is done in the same way. Here we see an area model for subtracting 1 1/8 from 2. Each unit is expressed as 8/8, so the subtraction becomes 16/8 minus 9/8, and the result is, of course, 7/8. In this slide, we subtract 1/8 from 2 units using a number line model. 2 is expressed as 16/8, and the result of the subtraction is 15/8. Children should be comfortable now with simple addition and subtraction on the number line. The next standard, 4NF-B3D, asks us to solve word problems involving addition and subtraction of fractions, referring to the same whole and having like denominators. Again, the standards suggest using visual fraction models and equations to represent the problem. I'm an advocate of creating word problems that capture the interests of children. So if all of your students are reading the same book or have seen the same film, choose a favorite character and create word problems around that character. When you present a simple problem, children should be able to solve it on the number line and in an equation. The standards move on to multiplication of fractions by whole numbers. 4NF-B4 asks us to apply and extend previous understandings of multiplication to multiply a fraction by a whole number. This standard is subdivided into 3 sections. The first section, 4A, reads, understand a fraction a over b as a multiple of 1 over b. For example, use a visual fraction model to represent 5/4 as the product of 5 times 1/4, recording the conclusion by the equation 5/4 equals 5 times 1/4. 1 over b is the unit fraction, so we're simply extending 4NF-B3, which was to understand a fraction a over b as a sum of fractions 1 over b, to see that a over b is now a multiple of 1 over b. Again, the standards ask us to use visual fraction models and also to write the equation. So in this slide, we used an area model to visualize 5/4 as 5 times 1/4. As we write the equations for this operation, children begin to realize that in order to multiply a fraction by a whole number, we must only multiply the numerator by the whole number. This area model helps them to understand why. What we are multiplying are 1/4. How many of these 1/4 do we have? Well, we have 5 of them. Using a number line model, this multiplication is straightforward. In this slide, the question is, how many 1/5 do we have? We have 2, 3, and 6 of them. Is it necessary to call 6/5 1 and 1/5? A good question. Sometimes it's better to use the fractional notation rather than the mixed number. This is especially true in equations. Once children become comfortable with multiplying unit fractions by whole numbers, the standards have them multiply fractions other than unit fractions. 4NFB4B says to understand a multiple of A over B as a multiple of 1 over B, and to use this understanding to multiply a fraction by a whole number. In this slide, the example given in the standards is translated into an area model. Recognize 3 times 2/5 as 6 times 1/5. In general, the standards are now defining the multiplication of a fraction by a whole number, n times the fraction a over b, as n times a over b. Here we see the standard modeled on the number line. We've multiplied 2/6 by 2 and then by 3. Again, when an answer is something like 2/6 or 4/6, should students convert this to 1/3 or 2/3? Both are correct, so it becomes a matter of what is easier to work with in an equation. Children should recognize equivalent fractions, but the conversion is not necessary. In this slide, we look at the idea of multiplication of a fraction by a whole number on the number line one last time. The important concept here is that n times the fraction a over b should be seen as n times a over b and computed as that. And this is really the final concept of the grade 4 standards. The next standard simply adapts the concept of multiplying fractions by whole numbers to word problems. 4NFB4C asks us to solve word problems involving multiplication of a fraction by a whole number. For example, by using visual fraction models and equations to represent the problem. And this example comes straight from the standards. If each person at a party will eat 3/8 of a pound of roast beef, and there will be 5 people at the party, how many pounds of roast beef will be needed? And between what 2 whole numbers does your answer lie? Of course, area models can still be used to visualize the concept. In this slide, we see an area model for 5 times 3/8, and a much more child-friendly problem using Eileen Spinelli's beloved Mr. Hatch. We also see an example of a necessary conversion to a mixed number. A mixed number is much more relevant when computing something like the number of pints of ice cream you have to purchase. In this slide, we see another child-friendly problem. We're using 3/8 of a cup of magic potion number 10 for each glass of a secret punch. If we want to serve a glass of punch to each of 5 friends, how many cups of potion will we need? On the number line model, we see 5 times 3/8 equals 15/8. So we will need 1 7/8 cups of magic potion. And if the potion comes in 1-cup containers, we should buy 2. The standards now move on to decimal notation, but Sam isn't ready to cover that. This has been a presentation of MathWord Press, dedicated to teaching children mathematics through literature, on the web at www.mathwordpress.com.